Today we're going to discuss the last section of Chapter 6, which is 6.5, Analyzing and Sketching Graphs. So this is a little bit different than the things we've done in the past, but this is important. You see a lot of questions about this on the state test. And if you just use a little thinking, it's not too difficult of a section either. So let's go ahead and hop in to this to understand what we're going to be doing. So it says Analyzing and Sketching Graphs. Graphs can show the relationship between two quantities without using specific numbers on the axis. So sometimes we're going to talk about situations where we don't have numbers, we just have labels for these axes, and then we have a graph that goes with it. And we'll talk about what that graph means and how we can make a graph. So the main thing is, what stuff we've talked about, like slope. If this line is going up, that's increasing. So over time, that distance is increasing. If you have a flat line, that is a constant. It's constant. It's staying constant. It's not changing. It's staying constant at whatever distance it's at. So it's staying constant, and then if it's going down, it is decreasing, obviously. These are all, here's another thing I do want to make sure I point out. These are all constant rates. This is a constantly increasing, this is constantly not changing, and this is constantly decreasing. If it's a straight line, it's a constant change or a constant rate. If it's a curved line, that's whenever you have an increasing or decreasing rate. We'll talk about that as well. But main thing to understand is if you have straight lines, you have constant rates, whether it be increasing or decreasing or not changing. So we're going to go ahead and jump into an example. This says the graph shows the temperature throughout the day in two cities. Describe the change in temperature in each city. So this is where you're going to use your words to describe the temperature in each city. So Belfast, the best way to do this would be to break down the graph part by part. So for example, this at the beginning of the day, the temperature's here, and it's doing this. So obviously, if it's doing that, it is increasing to start the day. So that's exactly what you'll write. The temperature, and I'm going to abbreviate some stuff, the temp is increasing to start the day. That's the first part. So then we get to the peak. We get to its highest temperature of the day, and then it starts to slowly go down, and then it goes quicker and quicker down. So with this curving downward more, this would say after the temperature increases to start the day, it then decreases slowly and starts decreasing at an increasing rate, okay, because it's going quicker. So you would say the temp then decreases at an increasing rate. The reason this is important, the increasing rate is the important part of this, because understanding that it is decreasing, but it's decreasing quickly. So it's slowly decreasing, but then it's quicker and quicker decreasing because it's curved. If it was straight, that's when it's constantly decreasing. But since it's curved, this is increasing or decreasing at a constant rate. Sorry, decreasing at an increasing rate. There's a lot to delve into that. So it says, again, just to review, Belfast, the temp is increasing to start the day. So as you can see, it's increasing to start the day, and then the temp decreases at an increasing rate. So then we have Newport. So Newport, the temperature to start its day was very high. Okay, it started its temperature very high, and then it decreased to start the day and since this is a straight line, you do want to make sure you put the temperature decreases to start the day at a constant rate. Constant rate is the key part of that. So it's decreases to start the day at a constant rate because it's going down quickly at this straight line. It's going down at a straight line, so if it's a straight line, that's a constant rate. Then in the middle of the day, it's flat, so that means the temperature stays constant or does not change. So you can say, then temp stays the same for a while. Then the temp stays the same for a while. And then to end the day, it increases. Then temp increases at a constant rate. Again, because it's a straight line. So if it's a straight line, that is increasing at a constant rate. So this is how you would describe each of those graphs. Obviously, you should be able to tell if it's increasing, decreasing, whatever. The main part is knowing the rate is increasing or decreasing at. If it's curved, it might be increasing or decreasing at an increasing or decreasing rate. But if it's a straight line that has straight parts, that means it's a constant rate in those parts. Okay, so let's look at another one and see if you can try this one. And again, there's no perfect way to answer these. It's really just making sure you are breaking it down part by part on the graph. So I'll give you a second, pause the video, try this. Okay, hopefully you've tried it. It says, the graph shows the path of two birds diving to catch a fish. So, first of all, this is the vertical distance, this is the horizontal distance. So you have a bird, it's flying, the pelican is flying, and as you can see, it's decreasing. So it's decreasing to start, so the pelican, if it's decreasing its vertical distance, that means it's descending, so it's going down. So you can say either descending or going down. It is descending so it's descending slowly to start, because as you can see, it's descending slowly here, but then it gets quicker, it quickly descends after that. So you can say it descends slowly to start, then quickly descends. So it descends slowly to start, then quickly descends, and then as you can see, it slows up as it's getting closer to the ground. So then you can say, after it descends slowly and then starts to descend quickly, it slows up again. So you can even say it slows its descent before reaching the ground. So then it slows its descent before it reaches the ground. Okay, so that's how you could describe your pelican. And then again, we have an osprey. So it starts its descent, but as you can see, it starts to descend at, since that's a straight line, you can say it descends at a constant rate. And then once it gets to here, it's still a constant rate, but it starts descending quicker. So you just say it descends at a constant rate to start. Then it descends at a quicker constant rate. Alright, so that's how we are describing these graphs. You're just telling what's going on with the graph, because there's no numbers, you're just telling with the situation what is happening. So that's kind of breaking down how we do that. Then they'll also have problems where you have to do it backwards. They give you the situation, and you make the graph. Okay, so let's look at an example of that. Okay, so here's a couple examples of these. So we'll do each of them. We'll start with part A. So sketch the graph that represents the situation. So we're going to have a graph. Looks like this. It says a stopped subway train gains speed at a constant rate until it reaches its max speed. It travels at this speed for a while, then slows down at a constant rate until coming to a stop at the next station. Okay, so first of all, you have to label your axis. I'm going to give you a hint, not always, but a lot of the time, if we're ever dealing with time, like if something's happening over time, which is happening here, we're talking about the time it takes to do something, that's always going to be your x-axis. Time is always your x-axis, because that's your independent variable, because that's always independent. So then your dependent variable in this problem would be speed. It's talking about how quick you are doing something, the speed at which you're doing it. So the key part is with these you have to break this paragraph down part by part. So the first important thing I see is a stopped subway train. So if it's stopped, what is its speed? 0. So if it's 0, that means it's starting right here. So this is where you're going to start, at the origin. So it says gain speed at a constant rate. So if it's gaining speed, it's increasing. And if it's a constant rate, it is straight line. So you're going to gain speed at a constant rate. That would look like that. Until it reaches its maximum speed. So this could be its maximum speed. It doesn't matter how high you make that. I mean, that's not going to be incorrect. As long as it's increasing constantly the whole time, that is fine. It travels at this speed for a while. So if it's traveling at that speed for a while, that means it's not changing. It's not going up or down. So that means if it stays at that speed for a while, it's constant, meaning it's not changing. So that would look like that. You have a constant, you're at that constant speed for a while. Then slows down at a constant rate until coming to a stop at the next station. So again, if it's coming to a stop, you'll have a speed of 0, and if it's slowing down at a constant rate, that is a straight line going down until you hit a speed of 0, which will look like that. Okay, so that is what your graph for part A should look like. So let's look at part B. Part B, it says, as television size increases, the price increases at an increasing rate. So, two things. So obviously it's very easy to tell what we're dealing with. Television size and price. Okay, so television size and price. First of all, if it says as television size increases, the price increases, that means that the price depends on the television size. So if the price is your dependent variable, it is your y-axis. So that means TV size would be your x-axis. Okay, so as television size increases, so that means as this is getting bigger, the price is increasing. So we know that we're increasing, but we're not increasing like this because it says that the price increases at a increasing rate. So let me show you what the difference between an increasing rate and a decreasing rate would be. So if it's increasing at an increasing rate, that means as the TV size gets bigger, this is curving up like that because the price is increasing at an increasing rate as the TV size goes up. So this is your answer to this problem. So that is what your graph should look like. If it was increasing at a decreasing rate, I do want